Okay, welcome everyone to today's seminar. So it's my pleasure to introduce Kristian Kiili, who is here from Finland. So he's actually a visiting scholar at the H-Star Institute for a year. Back in Finland, he is at the Tampere University of Technology, where he's leading the game lab there. He has a PhD in educational game design, and his primary interests are game learning, human-computer interactions, and also user experience research. And so, take it away.
So this talk today is about Semideus game, the game that we are currently developing. So it's not finished. It's like a service. It's never-ending story. So the game is about fractions and decimal numbers, and it's kind of weird to start to create a game about fractions because I have so bad memories about fractions in school and stuff. So let's start with a little story. Like 30 years ago, when I was a little boy, we had 2 pieces of candies, like package of candies, with my friend. They were fruit candies, and we were about to share the candies because they were a little bit different taste in those. So I had a 3 years older friend, my best friend, and he said that Hippu, that's my nickname in Finland. Nobody knows Kristian, so I'm Hippu. Okay, and he said that because you are younger, you should get more candies. So let's make a deal that let's take the first package, and for every 5 candy, you get 3 and I get 2. Okay, it sounds great for me. Yeah, let's do that. Then we take the second package, and he said like that. Okay, now let's take every 3 candies, and you take 1 and I 2. So basically, in the first package you get 1 more, and now I get 1 more. But in the first package you get like 3, and now I get 2. So I said, oh, awesome, yeah, let's go for it. And we shared our candies, and I was thinking, why is she laughing so much? So I was, oh, she's just waiting to get the candies and stuff like that. So do I. So, but in the end I realized that he was laughing because he was tricking me out, because I lose like 6 or 7 candies in that deal. So it was the first taste of ratio, what fraction actually means and how you can get tricked with that. But let's think about it in a little bit different context. Okay, it wasn't so much 6 candies, but what about the adults and fractions? If you take a look on your left, the person in your left, and then your right, and one of you is huge probability that you have some problems with understanding fractions properly. So it's not only for the schools, it's everybody. Even the teachers have problems with fractions. And if you think about it, not about candies, but you are making a business deal or something, 6 candies, 6 millions, it may have effect on your career also. But back to the school context, as I mentioned, teachers also have problems with fractions, and especially problems in pedagogical knowledge of fractions. So a lot of elementary schools teachers that don't actually identify if someone has some kind of misconception. They just know that, you didn't know that, but they don't know why they didn't know that. And there's a lot of new research about that, how it affects the learning and how bad the problem actually is. But if you think about, for example, comparison of these 2 fractions there. So 1 of 3 6th graders can't say which one of these fractions is actually the bigger one. Although there's a 50% chance to guess it. So it's something that we should really focus about our current teaching methods, because fractions are important because they were like a gatekeeper of higher mathematics and, for example, probabilities and so on. So this is a problem space that we are dealing with our game. So over the next 30 minutes, I'm going to tell you why our game can be used to teach fractions, hopefully more effectively than the current teaching method in schools. And every day when we ignore the scientifically proven methods to teach fractions, the current research result about teaching fractions, someone will lose candies, money, or maybe studying opportunities or something like that. So it's quite important to try to create new solutions for supporting this learning. So about the structure of the presentation, first I will show a little bit about how the game looks like, and then we talk about how we mapped learning science to the mechanics, and after that I will clarify our approach for the design, how we use different lenses to ensure that all the important aspects have been taken into account in our design. Hopefully you can get something for your own designs from this approach also. But it's quite loose approach, it's not like a very structured way. But let's first see how the game looks, and this is an older version of the game, not the current one, but it's a version that we used in some of the studies that I will be presenting the results. So I don't have the sound at the moment in these, but so the story behind the game is like the main character Semideus. He's a son of Zeus. Okay, let's wait. We see there the goblin has stole the money of Zeus, the golden coins, and the Semideus is chasing the goblin and trying to find the coins that the goblin has hidden in the trails of the Mount Olympus. And all the time, all the tasks that are related to the game are somehow related to the number lines. And we have two types of tasks. We have estimation task, and then we have comparison or ordering task in the game. So now the Semideus reaching the top, and hopefully he has done well and have some stars. So we can use different kind of number lines. The range can change, it can be negative, and so on. But maybe we don't look at this video more. Let's go to take a deeper look about the science behind these ideologies. So as I mentioned, we use several lenses to ensure that all the important stuff is taken into the account. And we use as these lenses like different well-known persons that have somehow contributed to the theme of that lens. And our first lens is learning scientist. And let's take some local person here. So what would Roy say about our design? What are the latest research results related to the learning of fractions and also EdTech in general? And this kind of thinking helps us to first of all identify some basic theories, the theoretical framework for our game. So one of those in this case is integrated theory of numerical development that we have used. Okay, here we have a situation. Semideus is here. This is a trap. You have to jump over it. So he's jumping over the trap, and here is like a task where the golden coin is hidden. It's somewhere here, there. And first of all, if you think about the integrated theory of numerical development, so first of all, it says that you should actually forget the pie charts, not totally forget, but emphasize more working on number lines. Another issue is that we shouldn't teach the number representations, whether decimals or fractions, separately. So we try to integrate them. For example, in this situation, you have both representations here at the same time. So if we go to the next slide about the comparison task or ordering task that you have to order from smaller to largest one, these stones. So for example, here we have an equivalent number representation. So for the students, it's very hard to understand that the same number can be represented with different kind of systems. You should note also that because we don't have the exact range on the number line, so only the order is important, not the place. But if you look at log data of the game, so several players use this number line to aid their thinking. So they are moving those in the place that they create their own mental number line, that this is like from 0 to 1, for example. And for example, those get that the first task that they do in the game, it tells a lot about, if they use this approach that they use a number line, then they know quite a lot about fractions. The students that don't do that, actually, they do hassling and everything, so they don't understand how to use, for example, this as a tool of aiding their thinking. Okay, if you think about the pie chart approach, that you have a pizza with like 5 slices in here. We have a task here like 7 divided by 5, and here we have a number line ranging from 0 to 5. So a lot of students have difficulties in this task because we have the same denominator as the range of the task. So how, if I have a pizza of 5 slices, how can I have 7 slices in that pizza? So they are strict to that pie chart approach. That is not true when we go to the number line. And for example, in our recent paper-based test, approximately 18% of students, I think we had like 80 or 90 students in this, when they estimate 7 divided by 5, they estimate it here, or they draw a further line that you can do it on number line on 0 to 5, you have to extend it. So it was quite surprising amount of those players or students at this time. Another concept, theoretical concept related to misconceptions of fractions is whole number bias or natural number bias. So for example, when you are comparing these two fractions here, the students they have learned the whole numbers, and they tend to transfer those properties to rational numbers. For example, here, they don't understand that this is about the ratio of that those numbers, but they think them as a separate. They first, for example, compare the nominators, like 2 is smaller than 3 and 3 is smaller than 5. So 3 divided by 5 have to be bigger than 2 divided by 3, although that is not the case. So they use this transfer effect in wrong ways. They don't understand that they are different, these systems. In decimal number context, it's a similar approach. Okay, we have like here, the student might think that in here we have 2 digits, and here we have 3 digits after point. This has to be bigger because there is more digits as like in the whole numbers. So these were like a basic misconceptions. I don't go any deeper details and other versions of those, but these are something that the game that we are creating tries to detect, and we are studying how these different misconceptions related to each other and so on. Then one final hard part of understanding rational numbers is about the density concept. So the student finds it challenging to understand the density of rational numbers. For example, in whole numbers, after 2 there is always number 3. After 3 is 4. But if you take, for example, this task here, we have created the task that you have two traps, 3 divided by 5 and 4 divided by 5. So a lot of students think that there are not any numbers between these. And now they have to estimate, find the coin from point 3 divided by 4, and it's between those traps. So we try to design the task of the game in the way that it creates cognitive conflicts with your naive conceptions of those concepts and in generally about the fractions. So actually there is like infinite number of fractions and decimal between those traps. So let's go to game mechanics. What would John say about what kind of game mechanics could be used? Okay, you already saw some of those mechanics that we are using, but here is like a simplified map of the basic elements that we have. We have worlds, levels, and then we have platforms. That the levels are created from the platforms that you use to climb up to the mountain. And in the platforms we have, of course, the player, the runaway, like a goblin that we are chasing. Then we can activate allies, and there is also some enemies. I don't go to this now in details because I will show example of these in a minute or so. But basically the approach is that levels are designed based on the curriculum, and you have to get enough coins and save enough your energy level to get into the top and open the next level in general. But let's take, for example, the enemies. So in the first versions we did not have any enemies, but when we collected some data about user experience, there were a lot of complaints that how can you have like a platform game without enemies that you can jump on? So we had to add some enemies there, and we wanted to add them in the way that they are actually somehow related to the concept of the game, that the concept of fractions or decimal numbers. So for example, I don't know how well it shows in here, but this creature here, he has like 3 spots, like pumping spots, and 1 empty spot there. So it represents like 4 divided by 5. So if you knock it in the right place, you get more diamonds. So it's related to the where you knock them out. And if you, for example, collide with that creature, okay, you lose energy, and energy affects about how you success in the game. But because of that, loss of energy is nothing to do with your mathematical skills. So we later on in the game somehow give you more energy, so health kit or something. So we want that it's kind of all the points and everything reflects what you know about this theme of the game. At the moment, this is bad design. It just came in the next level. So we are now thinking how we provide this energy in different ways, so it's not so obvious that you get always some more. So we create some kind of mystic boxes or something that the illusion that you have the affect to select something. It's at the moment we are thinking about it. Okay, sometimes it comes situations that the player is very confused. He don't know what to do. What's this fraction about, for example, here? So he thought first that, okay, it's one hole. No. Now he thinks that, I don't know. I have to use some diamonds and order this, my ally there, and the code shows the place, and you can continue. Okay, we don't take these into account when we are creating the analytics, what you know, but this provides interesting information. So like in the bigger scale, when we get a lot of data, what are the situations when students or players are avoiding something? Are there certain patterns that we can see? What are the most challenging concepts? So we use this as like a research tool to provide them possibility to do something, and it tells us something interesting, hopefully. At the moment we have so little data that we don't actually know yet what this provides, but we are eager to find out soon. In general, if you think about the whole game, so we made the validation test. We had 80 students first they make paper-based tests, similar concepts that are in the game, and then we check out what they tell about the knowledge level of those students. So there was a quite nice correlation between the data that the game provides and the paper-based test. Of course, we use different tasks or the different symbols in the task, so they weren't similar, but same type of task in those. But this gives us a good starting point that about thinking about the assessment value of the game. So, but we have had to think a lot of like balancing of what we can include into the game so that it still reflects your knowledge level. So it's always something that you have to take some fun out to make the assessment run. So we try to find new ways to provide the fun and at the same time assess them. And one important thing about, if you think about the assessment power of the game, is of course the user interface also. So the user interface have to be like easy to use and intuitive, so that the players don't make mistakes because of the user interface, and that way give the information is not valid that the game provides. So the next lens is about human-computer interaction. So what would Norman say about our game? I think he had a lot of things to say about our user interface, but first of all, if you think about the, for example, Norm's concept of gulf of evaluation. So we want to ensure that if player does something, he can really understand the consequences of his actions, and that way he can build the knowledge about the rational numbers. If the player gets wrong, can't actually understand the consequences, he can create misconceptions or something, so then our game is going in the wrong direction. One aspect is about that we have used in our user interface is embodied cognition. So our starting point was to avoid buttons in the user interface as much as possible. And okay, this is not only the Norm's suggestion, but Roy would tell us that hey, think about embodied cognition approach, how you relate physical aspects, gestures into your game. So the science behind this is like if you think about mental number line, it's spatially oriented from left to right. So if I'm tilting the tablet right as my character goes there, so it means like the number is increasing, and when I tilt to the left, it's decreasing. And the hypothesis of ours is that this kind of user interface could help those that have cognitive disabilities, and they can at the same time saw the character walking on that number line. So it's more concrete, so they don't have to think about the magnitude so much in their head, but they can use the game as a resource of their thinking. Okay. Norman could also ask us about what about these buttons here, for example, about how they are related to the activities. So for example, here I have to pick this stone up, and if you start to play this game the first time, I think you would tap that and try to pick it up. That's intuitive, that's natural. Especially now when the stones are looking too much at the buttons at the moment still. But we have done a lot of tests with children. So if you think, take a little bit bigger iPad and you are tilting and your fingers are not long enough to get in the middle. So it makes it actually harder to control the character. So that's why we had to create an external button to this activity of picking and dropping them off. It's like a compromise, but after playing couple levels, it gets quite intuitive, and we get good feedback from that also. So, of course, we have to also think what would a teacher say. Okay, our game will be targeted for the teacher, for the schools, but also to the mainstream. But if you think about the school context, we have to somehow support, for example, the starting to playing the game, managing the users, and of course, if you think about, for example, here is a paper-based test of the fractions from one class. So I had a very hard time to go this over. Okay, I can score them, but after that, can I say actually how well they did, who had misconceptions and what misconceptions? So we try to automatize those things for the teacher, that the teacher can use those to make meaningful activities in the classroom. So the game is actually can be also seen as a activity that provides you information that you can utilize in other teaching and integrate to the other classroom activities. So we have been creating the learning analytics side behind our game. So basically, every task we use different kind of keywords. This is just to show some of the keywords that we have. They don't necessarily make any sense for you, but I'm just trying to describe that every task have different keywords, and based on these keywords we can later on mine the data and check out a lot of stuff based on these. But it's like we have our own language to describe all the activities and also the context of the game world, because it can have also effect on the results. So based on these, we try to model the players' understanding and also detect the misconception. So this is something that are in very early stage at the moment. So we are now trying to finish the game, and then we will focus on this analytics side. But we have all the time keep this in mind. So we have created all the tasks and levels and stuff in the way that it can serve this approach that we are going for next. So currently we have a rough tool to the research purposes that we can collect the data and make some simple analysis. But we aim to create a simplified version of those for the teachers, and also thinking how we provide information based on this analytics to the players itself. For example, in our current data, if you think about the fraction whole number bias thing about fractions, and the accuracy on those tasks is in our current data is 47%, so it's quite low at the moment. So there are a lot of problems in this kind of task, and this represents 67% is about different other tasks that don't have the risk of this bias. This is quite low also, but if we take out the equivalent factors, equivalent numbers there, it rises something like 80% or something. So there are a lot of different concepts that are hard for the students. So this is like, based on this, we created our rule of thumb, like if you can't identify it, you can't improve it. So it's something like, it not apply only for the learning and misconception, but it's also the user interface. So you have to know how challenging the user interface and how it's working so that you can evaluate how valid information the game actually provides. And based on these analytics that we are creating, we do not only try to create some kind of charts or figures about how much there is misconception or something, but we try to also create meaningful visualizations, for example, the students. So our ally, the coach, could provide like hints that visualize your problems and try to create these cognitive conflicts between in students. And based on these, if you think about what we try to create as a tool for the teachers, so we try to implement also some kind of craft-based activities there. So that it's not only the game, but it can success that in your class you could do this kind of activity, so with scissors and papers and tangible things. So that's something that we started to think because we understood that there's a lot of problems with elementary school teachers' fraction knowledge also. Though if we provide pie charts, for example, or something, it's not always so easy to understand how big the problem is, and so we try to give suggestions to the teacher activities also. Okay, our game is about mathematics. We should also think domain expert. What would example kids say about our game? Kids have said a lot about our game, and we are making some research together. But for example, kids would ask about us, how could we support the onboarding? I like really much the kids' analogy between musical instrument and mathematical games. So how we can provide easy access to other games that you can just start to explore the games, that you don't have to know about fractions before you start the game. So we have tried to create something like that. We have different tutorials, we have different methods to show, visualize things, rulers. Then we have different, for example, lianas coming. We can use game elements, and when you are trying to find the coins, you get the feedback, and the feedback tells also how well you are doing, and basically you can learn about the concept without the previous knowledge. We have tested it now with a couple 6th graders, and they get the grasp of the game, but we don't have an actual experiment going on that yet. Okay, here is, for example, example of those lions coming there, helping you to divide the number line. We can use different, they can be time-based, they are based on your attempts. If you make a mistake, we can activate them more or something. So there's quite easy to vary these and create like a path that helps you in the game. For example, I don't know why we have lianas in the Mount of Olympus, but we had to have something animated because we make some eye tracking research, and for example those stones or torches that were there, a lot of student players didn't actually notice them at all. They were just in the background and they didn't use those. So we start with these animated, and hopefully later they can use also other stuff in the world to aid their thinking. Okay, here is one ordering task. The player is a little bit confused. He thinks that he is not having enough time, that the goblin will steal all the money, so he buys the code coming and takes the goblin away. So originally we wanted to add some kind of time pressure in that. It's always tricky to think about the math and the time, but from the analytics side we are interested about what the time would tell, and without any time pressure we don't know what they are doing. We hope that they are not now not going to the toilet or taking coffee or something, but now they will finish the level and then do it. So, but now you can buy time with the diamonds. So if you don't like the time pressure, you can use the diamonds to get rid of it. Okay. A couple words about the experimental stuff. So our aim is create a magnitude DOJO thing. Like we have now going some experiments with the ordering task in the way that okay, we have like a stone that is 1 divided by 2, and then we have like other stone like 3 divided by 4. So based on these magnitudes we address the weight of those stones. So if you take a bigger stone, it's heavier and you move slower, so you can feel the magnitude of those. And we are also trying to do something with the sound. How could we use sound to provide information of the magnitude? So these are something that we are playing with. I don't know what ends up to the game, but if you think about the fate, for example, that could also be used to create a puzzle-like element. You have a time because the goblin is stealing the money, and you have to decide what stones should I move first, because some of them are heavier. So it could provide more gameful elements at the same time. Okay, at this point you might wonder why I didn't talk about the actual users, the players at all. But one of the most important lenses that we had, what would our my kids say? So I have a testing laboratory at home, and at the moment, in the beginning they are like, I didn't get much from that, but then they realized that you have to give negative feedback, and now they are giving me a hard time all the time. And I have used this laboratory maybe too much, because a couple of weeks ago they realized that, hey, you should be paying for us for this. So I have to give some gifts or money or make new children or something so, to get this going. But this is like a stepping stone. We first try this, and then if we get the green light, then we make some field tests with a bigger audience. And in our real test, we usually make some measurements-based flow experience. So we think, what would Kristian Kiili say about our game? And actually, every time when we are making design decisions, we think about flow theory and the most important dimensions of flow. For example, challenge skill balance, immediate feedback, sense of control, clear goals, and so on. So they are very good tools to think about your game. So what would Flow, or what did Flow say in our pilot study? So this was a very good result for us, because this study is about the thing that we did together with kids, and we didn't have all the game mechanics in our game, because we used our game as a pre and post test. So we take a lot of things out of the game. It was like a measurement tool, and still we got very good scores in terms of flow. And one very important, interesting thing is like loss of self-consciousness was scored the highest. So the players didn't think at all what others were thinking about their playing behavior, that somebody is evaluating them. And all what we actually were doing was evaluating what they know about the fractions. So it's a promising approach if you think about the assessment in games, that you can really concentrate about your own knowledge and show it through the game without that pressure about the evaluation. So we could got a couple things about the study that we made with Keith. As I mentioned, we used our game as a pre and post-test and bootstrap in the intervention, like 4-week intervention there. And our game was played like 40 minutes in the beginning and 40 minutes afterwards. If you think about pre-test results about bootstrap score after the intervention and the knowledge about conceptual knowledge about numbers. So there was quite high correlation. So there's something going on with problem solving, mathematical thinking, and your level of numerical understanding of the basic conceptual knowledge. This was based like 80 players, so it was quite small. But when we get a little bit smaller, we get good data from 12 students about the bootstrap group and the control group of only 16. But as we can see, this is like, here is the pre-test and here is the post-test results. And there were big difference in these two game groups when they started to play the games. But in the end, they were quite the same. So this is although this is a very small sample, but if you remember the first lecture when Keith was presenting the results of other study with other measurements, so the figure is almost the same. So it's a similar. So although we have a totally different measurement system in here. So it's interesting, and this was like our pilot study, and now we are going to collect a huge data and check out what's behind this phenomenon. So, will the Semideus save the world? I don't think so, but I hope that if kids play the game, they don't lose candies anymore so much as I in my youth. But our aim is to distribute the game very widely, so we have now a nice thing going on here with Keith and other researchers in Stanford about making like a math video game study service that teachers can select the different kind of math learning packages related with some tests, and we try to collect data in different cultural contexts and so on. So we will start that hopefully in the fall after the summer. So we are now preparing those issues behind that. But in the meanwhile, so we will get our game to the App Store like in the fall after the summer, maybe during the summer. But in the meanwhile, if you are interested, you can train your working memory to get better also in the Semideus game. So we just released a couple of weeks ago working memory training game. So it's now in the App Store. So check it out and test your cognitive abilities in that. I think that was like all that I have from this concept. And now I'm open to any questions and comments and so on.